Hello everyone, this is our second and last lecture for Chapter 7, for distributions. In this lecture video, we will introduce briefly the F distributions and chi-square distributions. So let's talk about F distributions. Like Z and T distributions, the F distribution is a continuous probability distribution. Like the T distribution, the F distribution is a family of distributions. Unlike Z and T distributions, the F distribution is positively skewed or skewed to the right. The shape of the F distribution depends on the degrees of freedom associated with the numerator and denominator. The total area of an F distribution equals 1. As degrees of freedom increase, the distribution becomes less spread out. The F statistic is calculated as a ratio of two variances, each with its own degrees of freedom. The larger variance is usually the numerator of the ratio, so the F statistic is usually greater than 1. The F statistic compares variance between samples to variances within samples. This is known as analysis of variance. More on this in Chapter 12. The chi distribution, like the T and F distributions, are a family of distributions with total area of 1. Each chi-square distribution is determined by its own degrees of freedom. Unlike the normal and T distributions, but just like the F distributions, chi-square distributions are positively skewed or skewed to the right. The shape of the chi-square distribution depends on its degrees of freedom. The value of chi-square is always positive, and as degrees of freedom increase, the chi-square distribution becomes more symmetrical. More on this in Chapter 13. Before we move on to the next chapter, just a quick review and some connections. There are many theoretical distributions, both continuous and discrete. We use 4 distributions a lot: the Z, or standard normal distribution, T, F, and chi-square. Z and T distributions are closely related to sampling distributions of sample means, because we're comparing sample means to population means. F and chi-square distributions are closely related to sampling distributions of variances, because we're comparing sample variances to population variances. The next video lecture is on Chapter 8, confidence intervals, one type of inferential statistics.